This lesson is going to review some of the major concepts for atomic theory, so make sure you're taking notes so that you are an active listener. The first thing we studied for this chapter was the structure of an atom. So you should know that there's a nucleus, which is in the center of the atom, and in that nucleus we have protons that are positive and neutrons that are neutral. Surrounding the nucleus we have rings. We call these energy levels. And in those rings are electrons. Now, they're not actually rings, so we call them rings and draw them that way for simplicity, but they're actually clouds because we only know the probability of where electrons are located. This current model is called the quantum mechanical model. And it's the one that has the fuzzy clouds. You should also understand the relative masses. So compared to each other, we know that the protons and the neutrons weigh about the same, so we'll just call that 1. And then electrons are so small that we consider them to weigh nothing. You should be familiar with this symbol. So we have an element, and then you're going to have lots of numbers. And you need to understand what these numbers are telling you. This top number here is called the mass number. And this includes both the protons and the neutrons because they both weigh something. It does not include the electrons because, like I said, they're so close to 0 that we consider them to weigh nothing. Then we have this bottom number here. This is called the atomic number. And this is the number of protons. The reason this one is important is because this one identifies the element. It identifies the element. So in other words, however many protons it has, that determines which element that particular atom is. And then the last thing is the charge. Now this one has to do with the electrons, but it's not the number of electrons. It tells you what it did with electrons, and it's opposite of what you think. So +2 actually means that it lost 2 electrons. So the total for this atom, if it was neutral, it would match the protons, because the protons are positive and electrons are negative, so they have to cancel out. This one is has lost 2, so again, if it was neutral, it would have 12 electrons, but since we lost 2, this one is going to have 10 electrons. The next thing you need to know are some vocab words. We're going to start with valence electrons. Valence electrons are the electrons in the outer shell, and they're really the only ones we care about because they're the only ones that can be traded and shared and transferred during chemical reactions. So the reason that these are important is that they determine the chemical and physical properties. So when I say the properties, I mean things like how well do they react with nonmetals or with metals, whether they're reactive or not in general is going to be dependent on those valence electrons. And in the columns, so the up and down columns on the periodic table that look like this, these on the periodic table have similar properties. And the reason they have similar properties is because they have the same number of valence electrons. So everything in the oxygen column is going to react about the same as oxygen because they all have the same valence electrons. And when we're talking about valence electrons, 8 is the magic number. We call that the octet rule. So atoms are going to try to gain or lose or share electrons to meet that magic number of 8. The next thing you need to know are 2 words that both start with I, and you don't really use either one of these in your everyday life. So it's helpful to review them. The first one is isotopes. Isotopes are elements that are the same. So if we have 2 elements of carbon, in order to be carbon, they have to have 6 protons, so they have the same atomic number. But they don't have to have the same neutrons, and neutrons do weigh something. So if the first one has 8 neutrons, that would give us a mass of 14. The second one has 6 neutrons, that would give us a mass of 12. These 2 are called isotopes of each other because they're the same element, but they have different masses because of different neutrons. So the words that you want to think of when you see the word isotope are neutrons, because they have different neutrons, and mass, because the neutrons change the mass. Ions, you want to think of the word electrons, and charge. So these are things that have gained or lost an electron, which gives them a charge. Remember that it's opposite of what you think, so gaining electrons makes it negative, losing makes it positive. And there are certain words that we use for positive versus negative. So a positive ion is called a cation. And remember, the way you can remember that is to look for that lowercase t in the middle of the word that looks like a plus sign. And then negative is anion. The next thing we want to talk about is electron configuration. So if you remember on the periodic table, it's kind of broken into 4 sections. This is the S, P, D, and F. S's start on 1, and then you can go down from there. P's start on 2, D's start on 3, and F's start on 4. So you can number your S, P, D, and F, and you can have all the energy levels. And what you're going to do is go left to right, up and down, and you're going to write the electron configuration, and you end up with things like 3s2. And you need to know what all of that stands for. So just a reminder, the big number in front stands for the energy level. So this is going to tell us how far it is from the nucleus. We're talking about regions of space around the nucleus. The letter is going to describe the shape of the region. So remember, S looks like a sphere, P looks like a peanut, D looks like a double peanut, and then F is a question mark. So the combination of the 3 and the S is describing a region of space. And then this little number is telling us the number of electrons in that region of space. So the 3s2 is telling us that we're in the 3rd region from the nucleus. It's shaped like a sphere, and there are 2 electrons in that region. We also can talk about orbital notation, where we draw the electrons as arrows instead of just listing how many. When you're asked for orbital notation, if you can list out S, P, D, and F, 1, 3, 5, 7, that will help you. So if we were doing an orbital notation for something that had like 3s2, we would put 3s and then an up-down arrow. And then let's say that it had 3p4. First of all, I'm going to draw 3 lines for the p, not because it has a 3, but because of this right here, for P, you always draw 3. And then the rules for these arrows are that you can't put more than 2 arrows per line. You have to put 1 arrow per line before you come back for seconds. So if we have 4 arrows, we're going to draw it like this. And then the last rule is that you'll never have 2 ups or 2 downs. Make sure that if you have 2 in the same line, that they're going opposite direction. And the last thing for this chapter is if you describe frequency, energy, and wavelength. You need to know the relationships between these words. So F stands for frequency, E stands for energy, and W stands for wavelength. So in your reference packet, there's a picture of, it looks like a target, it's a picture of an atom. First of all, you need to know how to use that picture, so you might need to review that, where the electrons jump from one energy level to another, and they release energy as they jump down energy levels, and you can see what kind of energy they release. So sometimes it's in the ultraviolet range, sometimes it's in the visible light range, and if it is visible light, you can jump down and see what color it is. You also need to know the relationships between these. So remember, F and E look kind of similar. They're almost the same letter except for that little line at the bottom. So these are a direct relationship. So if one is high, the other one is also high. If one is low, the other one's also low. But wavelength is inversely related to both of these, or indirect. So if wavelength is low, it means you have a high energy or high frequency. So on your electromagnetic spectrum, it tells you how long the wavelength is. It tells you one side is a short wavelength and the other side is a long wavelength. You need to know that the longer the wavelength, the lower everything else is. So a low wavelength would mean a high frequency and energy. And that's it for the first chapter.